Teams can spend weeks fine-tuning a model to fix a problem that was never about the model. The right document was sitting there the whole time. The system just could not reach it. RAG and fine-tuning are not two ways to teach an AI the same thing. One changes the information available when the model answers, the other changes the behavior the model has learned. Choose the wrong one and you can lose weeks solving the wrong problem. By the end, you will have a 2-question test that tells you whether a use case needs RAG, fine-tuning, both, or neither. Stay for use case 2. It looks like an obvious fine-tuning problem. It is not. We will follow one system, an employee assistant that answers questions about benefits, security procedures, and company policy. It gives an outdated answer about parental leave. Someone says, let's fine-tune it on all our documents. Then the policy changes again. The fine-tune model does not update itself. New examples, another training run, evaluation, redeployment. Suppose this team's tuning cycle takes 2 weeks. Refreshing its policy index takes 20 minutes. That is the first surprise. Fine-tuning is usually not how you teach a model yesterday's company policy. That is a knowledge access problem. And that is where RAG begins. Someone asks about parental leave. The system searches the company's documents, selects relevant passages, and places them in the model's context before it answers. The model was never retrained. You change the evidence available for that request. That makes RAG a strong fit for private, frequently updated, or source-grounded information. RAG changes what the model can see before it answers. More precisely, it changes the context available at answer time. But RAG has a failure mode that can be worse than returning no answer. A wrong answer that looks well supported. Quick question. If your assistant gave a confident, cited, completely wrong answer, how long would it take your team to notice? Someone asks about parental leave. The retriever pulls last year's policy. The model produces a polished answer with the citation grounded in the wrong evidence. A vector database does not fix weak retrieval. Chunking, search, filtering, ranking, and evaluation determine whether the right passage ever reaches the model. Even a frontier model with weak retrieval can still be confidently wrong. RAG does not remove the hard problem. It moves part of it from model training to information retrieval. Now the same assistant has the correct information but behaves incorrectly. HR asks it to log a request. Sometimes it returns valid JSON. Sometimes it adds an explanation. Sometimes the category labels drift. That is not primarily a knowledge problem. It is a behavior control problem. Fine-tuning trains the model on examples of the behavior you want. How to classify, how to follow a response pattern, how to use domain terminology, or how to perform a specialized task more consistently. Fine-tuning changes what the model learns to do, but fine-tuning is not a dependable replacement for a searchable knowledge base. A model can learn a task pattern without becoming a current, reliable store of every fact in your documents. When those facts change, its weights do not update themselves. So remember, RAG changes the evidence. Fine-tuning changes the learned behavior. Miss that and you can understand both perfectly and still ship the wrong architecture. Now the decision test. 2 questions. 1. Does the answer depend on information that changes, stays private, or lives in an external source? Knowledge problem. Evaluate RAG. 2. Does the model need to respond differently, more consistently, or in a specialized pattern? Behavior problem. Start with prompting, schemas, structured outputs, and validation. Only if those controls fall short should you evaluate fine-tuning. Not every behavior problem requires training. Now test it. Decide before I answer. Use case 1. The assistant must answer from policies updated every month. Knowledge problem. RAG. Use case 2. The assistant already has the correct customer data, but every issue must use the same JSON structure and land in one of 12 approved categories. Many teams jump to fine-tuning because the output is inconsistent. But that mixes 2 different problems. Strict structured outputs can constrain the response to the required schema and allowed category values. That does not guarantee the chosen category is correct, but it does mean you do not need fine-tuning merely to stop the model from breaking the format. For output shape, do not train toward a probability when your application can enforce a constraint. Start with the schema. If classification accuracy is still weak after evaluation, then fine-tuning may earn its place. So the first answer is neither. Use the simpler deterministic control first. Use case 3. A compliance assistant must retrieve current regulations and produce every answer in an approved risk assessment format. Hybrid. Use RAG for current evidence. Use structured controls for the format. Use fine-tuning only if the remaining behavior, such as specialized classification or recurring edge cases, still needs improvement. Choosing only one may leave part of the problem unsolved. Strong teams do not begin by asking, RAG or fine-tuning. They ask, what exactly is failing? No information? Retrieve it. Wrong output shape? Constrain it. Correct information and structure but weak task behavior? Evaluate fine-tuning. Both problems? Use both. With separate jobs. Retrieve the facts. Constrain what can be enforced. Train only what must be learned. Save the 2-question test. It is the part you will reuse. And if you want the retrieval half done properly, the next video breaks down the techniques that actually move RAG performance.